over here. Myself, Push. This work, a novel heuristic-based heart disease detection framework for imbalanced dataset, is conducted at IIIT Sri City with my co-authors, Dr. Gori Raghavendra Narayan and Dr. Odelu Vanga. In this, what happened? Like there was a lot of issue. There was a lot of deaths going on due to the heart disease. According to some data, there was approximately 17.9 million deaths every year, which caused due to the heart disease. So it creates a need for effective classification of the heart disease before going to its severity level. It means, like earlier we detect the severity level of a person having the heart disease, better we can cure it. So machine learning can be used for this type of task as it has the capability to find the underlying non-linear features. But the challenge was that all the data sets which are present over there were highly class imbalanced. With the class 0, it means no disease, was approximately 53.4%, and the class with the highest severity of disease was only 4.4%. So there is a highly class imbalance, and in such cases, what our ML model generally do is say, okay, whatever the data will be given to me, I'll say it is class 0, and at the end of the day, it gets this 54% accuracy and say, okay, my work is done. But what we have to do, we have to give more importance to the severity, because if a person is not having a heart disease and it gets classified as a heart disease, it's not a big problem. But if a person with severe heart disease get detected as no heart disease, it's a very big problem, as it can cost a living being life. So for that, our technical problem was, basically we have to classify that not only if the person is having heart disease or not, we have to classify what's the severity of that. So for that, we chose the heart disease dataset named Cleveland dataset. It is a highly benchmarked dataset in the heart disease domain. It has 5 labels: 0, 1, 2, 3, 4. 0 means no disease, and 1 to 4 represents the increasing order of the severity of disease. So it's a binary classification. There is some literature review on that. The random forest, Javed et al. Tried a random forest with random search algorithm on the binary dataset of it. He considered 1, 2, 3, 4 severity of classes at just having heart disease, and applied the binary classification on that, and they achieved 93.33 accuracy, which proved the robustness of random forest plus RSA here. So we also did the same for our further research. Now, in case of the multi-class classification, the most powerful machine learning tool is that the XGBoost or the boosting family was just able to achieve 65.8%. And even the highly computational models like ResNet 50 achieved the 76.00 accuracy, but this ResNet 50 is highly computationally expensive. So what our task was, we have to create something. And the second thing also, the ResNet 50 is a deep learning model, so it lacked the interpretability skills. So what our problem statement was, we have to create a model which is more accurate, especially in the terms of recall, as the severity matters, as well as we have to reduce the complexity and increase the interpretability. So for that, our whole problem statements was divided into 3 phases. The first phase was to tackle the class imbalance. We have to create the synthetic data out of it. So for that, we account multiple techniques like SMOT, ADASIN, and multiple variants of SMOT. And then after that, we created a tree structure in which, instead of classifying everything at once, we started like a tutorial approach. What does child do? First of all, we give him some simple task. After that, we say, okay, now you have correctly done this task. Now let's increase the complexity by a little bit. So we have followed that approach in this. And after that, at each branch, we have added a heuristic-based, recall-based heuristic. So basically, our model is something like this. First of all, we'll be processing the data. And after that, instead of asking the model directly to tell us the severity, we just ask him, tell me if the person is having disease or not. That's it. After that, once the model said that, okay, the disease is there, after that only, we will try to classify the exact severity level. And so in the phase 2, we will be classifying 2 different levels of severity. And in the final stage, we will be classifying individual level of severity. Is that if in the first stage, the output is 0, it will be considered as 0. Otherwise, after phase 2 or 3, it will exactly tell us about the severity of the level. So doing this approach was actually better than the other models. Even it even surpassed the ResNet 50 by 1.5%. Also, out of it, we tried multiple data generation techniques. So out of that, we find out that the Edison is the most appropriate technique for this, which gave us the best result of 77.44%. So the key findings was that Edison was the best oversampling technique in the case of clinical imbalanced data set, as well as our overall model shows the improvement of 1.44% in terms of accuracy. And the biggest thing is it also increased recall by 3.11%, which is the most important thing in the case of clinical severe data. So our main thing was it was interpretable, as the random forest is known, or all the tree-based algorithms are known for its interpretability. At any time we can get to know why it is predicting this value. So the interpretability was the main thing we get from here, as well as it is for the clinical relevance, as the doctor is not only supposed to tell the output, he is also supposed to tell why the person is having that disease and how to cure that. So that's why interpretability and the clinical relevance was very high in this case. The conclusion is we proposed the model and showed that the Edison was the best oversampling technique, as well as instead of classifying everything at using a single model, we should break it into much simpler tasks, which usually give us the best results. Thank you. That's it from my side. Any questions?
Is there any question?